That is the general equation of sine waves. 2 pi ft is equal to 2 pi t over t. The small letter t is the time variable. The capital letter T is the period of the periodic waveform. The units of time and period are both seconds, which will be cancelled off in this division. The unit of pi is radian. Therefore, the unit of 2 pi ft is also radian. 2 pi ft is often numbered up as a single variable theta. This sine function equation is sometimes simplified to be a sine function equation. Conceptually, the expression 2 pi ft can be treated as an angle. An angle is measured in units of radians and degrees. Very soon you will learn to convert radian to degree and degree to radian. At any point in time, a sine wave has a magnitude value. For example, at time t1, the voltage of the sine wave is equal to V1. At time t2, the voltage value is V2. V1, V2, V3 are the instantaneous voltage value of the sine wave at time t1, t2, and t3 respectively. The instantaneous magnitude value can be calculated from the general equation of sine waves. If 2 pi ft is replaced by theta, the general equation of sine wave can be written as this. Vt is the instantaneous voltage at time t, or we say that Vt is a function of time. Similarly, V theta is the magnitude of the sine wave at angle theta, or we say that V theta is a function of angle theta. Now you learn to convert an angle in units of radians to degrees. Since pi radians is equal to 180 degrees, dividing this whole equation by pi, you have this equation. Now we have 1 radians is equal to this. So 2 radians is equal to 2 times of this, 3 radians is equal to 3 times of this, and in general, theta radians is equal to theta times 180 divided by pi degrees. Example 4. A sine wave has a frequency of 2000 Hz. Determine the angle in A radian and B in degree at the instant of 50 microseconds. Part A, theta is equal to 2 pi ft. Substituting 2000 Hz to the frequency and 50 microseconds to the time, we'll get theta to be 0.6283 radian. Part B, convert 0.6283 radian to degree. We multiply 0.6283 with 180 degrees, then divided by pi, we'll get 3.6 degrees. Now you learn to convert an angle in units of degrees to units of radians. Since 180 degrees is equal to pi radians, divide this whole equation by 180, use this equation. Since 1 degree is equal to this, theta degrees is equal to theta times pi divided by 180 radians. Example 5. A sine wave has a frequency of 200 Hz. Determine the time to reach 36 degrees after crossing zero level. The key point to solve this question is to apply this formula theta equal to 2 pi ft. We can use this formula to find the time t, but 2 pi ft are in units of radians, so we cannot substitute 36 degrees to theta directly. We need to first convert 36 degrees to radian. To do so, we apply the formula we just learned. 36 times pi divided by 180, we can convert 36 degrees to 0.2 pi radian. We keep the value pi here because later on in this calculation the pi can be cancelled off. In such way, we will get the more accurate final answer, 500 microseconds. This figure shows you the common angle we use in units of degrees and units of radians. For example, 0 degrees is 0 radian, 45 degrees is pi over 4 radians, 90 degrees is pi over 2 radians, 135 degrees is 3 pi over 4 radians, and 180 degrees is pi radians. Example 6. Write down the sinusoidal equation for this waveform. The general equation of a sine wave is this. The peak value is given in the question, 300 volts. Frequency is not directly given. Usually we calculate it from the period. But the period is also not clearly indicated. But we have 3 timing values in this waveform, 0, 0.1 second and 0.2 second. Within this 0.2 second, we have 10 cycles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, we can find the period by dividing 0.2 second with 10 cycles. So each cycle lasts a duration of 20 milliseconds. That is the period. Frequency is equal to 1 over period, so 1 over 20 milliseconds is 50 Hz. Now we are ready to write the equation for the sine wave. Refer back to the general equation. Substitute V peak with 300 volts and F to be 50 Hz. So we get this equation. 2 times 50 is 100. So this will be the equation for the sine wave. And usually we don't multiply 100 with pi because pi is a prime number. It has infinite number of decimal places. Keep it this way, it is more accurate.